Hi class. Change in plans for the day. Miss Gina had to cancel at the last minute, so we are going to continue on in our blue note packet. So take a second and get out your blue note packet and open it up to Scientific Notation 4-4. We will skip ahead to this section, so it's a little bit easier than some of the other stuff that's new. Scientific notation, I know, is one of the things that most of you said you had seen before when we talked about that yesterday. So here we go. So scientific notation is a way of writing numbers that are very large or very small. And that's why it's used, because so many people, when you're copying down little bitty numbers or very big numbers, they have so many zeros in them that it gets to be a tedious thing. So we found a shortcut. A positive exponent moves the decimal to the right, because that makes the number bigger. A negative exponent moves the decimal to the left, because that's making the number smaller, very small. Okay, when you express numbers in scientific notation, just going to abbreviate scientific notation, you must write the number as the product of a power of 10 and a decimal that is greater than or equal to 1 or less than 10. So it's to be 1 or bigger than 1, bigger than or equal to 1, but less than 10. So that's going to be like the way to figure out where you're going to put the decimal point, because you know that the decimal part of it has to be between 1 and 10, and then it'll always be a power of 10. Okay, so let's move on down to some of the examples. If necessary, you could pause and go back if people are still working. Okay, so let's write each number in standard notation. So right now, if you look at these numbers 1, 2, and 3, they were all in scientific notation. And we want to put them in standard notation, which makes them look like regular numbers that we see every day, like 3,257,000. Something like that. Okay, so we're going to start with, look at where your decimal point is, and you want to move it. It's going to be multiplied by 10 to the 8th. Well, we talked about yesterday that would mean that it would have 10 to the 8th would have 8 zeros on it. Because if you remember from yesterday, 10 squared equals 100. 10 to the 3rd would equal 1,000. So 10 to the 8th would have 8 zeros. Well, so what happens when you multiply that times 4.6 is you're moving the decimal point. Well, one of the zeros you have to take up for that you're moving it from the point in front of the 6 to behind the 6. So that would take up one of the zeros. So now you have to move it 7 more spaces. So you're going to add 7 zeros to there. So you have 4, 6, and then 7 zeros. 4, 5, 6, 7. And then I'm going to check it to make sure that that makes sense. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that works. That's where I was. Whoops. Took away one of the zeros when I did that. Okay, so I'm going to add my commas. 1, 2, 3, 1, 2, 3. So that helps too when you're counting 3, 6, 7. Oh, I guess it took away 2 zeros. thing I have an eraser. Let's try that again. 4, 6, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, comma, 1, 2, 3, comma, and that would be 3, 6, 7, 8. So that works. And that's our number in standard notation. Okay, so let's think about what's going to happen when we multiply by 10 to the negative third. It's actually going to make the number very small. So this is a scientific number that's really small. So we're going to write down 2, 3. Here was the decimal point, and we're going to move it 3 spaces to the left. 1, 2, 3. And put zeros in front of it. And then we can check our work, that it was 1, 2, 3 spaces where the decimal used to be and where it is now. Oh my. Okay, so we went from 2.3 times 10 to the negative third to 0.0023. Okay, the number 3 then, so go ahead and try that. Okay, number 3 then, you should have thought about moving it 2 spaces to the right to get 5, 5, 5, and then we would need to add 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So to check again, we moved it 3, 6, 9, 10 to get us back to the where the original decimal point was. Okay, so moving on, whoa. This thing is very sensitive. Okay, so now going the other direction. Oh my goodness. Write each number in scientific notation. I actually think this way is easier in some ways. You take it and look at the number, and you first want to figure out where do I put my new decimal point. So as of right now, my decimal point is back here. And you want to figure out where to put it so that it forms a decimal between 1 and 10. So if I put it here after the 6, that would be 7,456. If I put it here, it would be 745, 74.5, and 7.4. 7.4 is between 1 and 10, so that's where I want my new decimal place to go. Right there. So I'm going to rewrite it as 7.456, and then it's always times 10 to the what power. So now we go back and we count how many spaces do we move it. 3, 6, 7, 8, 9. So 7.456 times 10 to the 9th power. It was a really large number, so it has a positive exponent. So looking at this one, really large number, so it's going to have a positive exponent. So it's going to be something times 10 to the what power. So we're going to go back and we're going to count how many places here was our decimal point, and where do we move it so that we get a number between 1 and 10. If I move it here, it would be 30. In between this 3 and 0 would make 3.0. So that's what I want. I want it to be 3.0 or just 3. You could have either 1, 3, or 3.0. And now go back and count. How many places did we move it? 3, 6, 9, 12. So 3 times 10 to the 12th power. Okay, moving on to number 6. This one is a really small number. So if it's small, we know that it will have a negative exponent. Okay, so the large numbers will have a positive exponent. And small numbers will have a negative exponent. So here is our decimal point right now. Where do we put it so it forms a number between 1 and 10? If I put it back here, it would be 204. Here, 20.4. Or here, 2.04. So which of those is between 1 and 10? The 2.04. So we rewrite it as 2.04 times 10 to the what power? So again, we go back up to the top, look at our problem. Here's the decimal point right now, and we needed to end up at the 2.04. So we count how many places over. Put that decimal point in. So how many places do we move it? 1, 2, 3, 4, 5, 6, 7. Sometimes you should count it twice just to make sure you didn't make any mistakes. So here was the decimal. Whoa. So 1, 2, 3, 4, 5, 6, 7. So 2.04 times 10 to the 7th. What mistake did I make though when I wrote it? So I moved it 7 times, but what did I look at first when I first started? It said a small number should have a negative exponent, so I need it to be to the negative 7th power there. 2.04 times 10 to the negative 7th. Okay, so let's move on down to the next section a little bit. The last word problem. The distance from Earth to Mars is 7,839,000 kilometers. The satellite traveled from Earth to Mars 100 times. How many kilometers did the satellite travel? Write your answer in scientific notation. So if you think about that, you'd be doing it 100 times back and forth. 100 times means you times it by 100. So you take, if I take 7,839,000 and I times anything by 100, remember I add 2 more zeros to it. So I really end up with 7,839,123 and then 2 more zeros. So where are my commas? 1, 2, 3, 1, 2, 3. So I have 783,900,000. Putting that into scientific notation then, I am having a very large number, so I'm going to have a positive exponent. Where will I put my decimal point so it forms a number between 1 and 10? This would give me 78. This would give me 7.8. So I'm going to have 7.839 times 10 to what power? So now you need to count the swoops. 3, 6, 7, 8. Positive exponent. 7.839 times 10 to the 8th. Oops, label it kilometers. Okay, that's it for today. Thanks for bearing with me on all my little mistakes and the pen moving.